thought that there were only four elements: air, water, earth, and fire. Objects with fire in them could burn. When they were burned, they released this fire, then the objects only contained all the other elements within them. We know today that this is very false because of our understanding of heat.
Scientists realized that there are more elements than four, so they came up with another theory. They said that all things that could burn contained this invisible fluid called phlogiston, and when an object burned, the phlogiston was released. This theory was later disproved using magnesium. When the magnesium burned, the product after was heavier than what came before. So how could something have left it?
The next theory that came about was the caloric theory. During the late 1700s, it was proposed that the caloric, or heat, was a massless fluid that was found in all substances. Caloric flowed from one substance to another, but could not be destroyed or created, which would have been the beginning of the first law of thermodynamics. An example of this would be a melting ice cube in a jug of water. During this time, the caloric theory explained all of heat observations that have been made. A unit was even created called the calorie, which defined the quantity of caloric that heats 1 gram of water 1 degree.
Benjamin Thompson, more commonly known as Count Rumford, said that there's no such thing as caloric. He said that mechanical energy could be converted into heat, like when I rub my hands together, and then that heat could be converted back into mechanical energy. He proved this by boring holes in cannons.
Not much has changed since Count Rumford's theory. However, 3 laws have been created to explain thermodynamics. The first law is that all energy cannot be created or destroyed, but can be transformed from one form to another or transferred from one object to another. The second law is it's not possible for any process to remove thermal energy from an energy source and convert it entirely into work. These laws explain how thermodynamics works.
Over the last millennia, humans have tried to convert heat into mechanical energy through many different ways and forms. They've used many different machines to try and do this. These machines have become more and more efficient, up until the point where they're at today.
The steam engine is responsible for a lot of stuff we have today. For example, you wouldn't be watching this video if it weren't for the people who came up with the steam engine. Using your phone, watching TV, driving a car, going to the moon, all exist because of the Industrial Revolution. This is because most people that lived before the Industrial Revolution were farmers, but the steam engine allowed people to pursue different inventions which exponentially increased population, technology, and exploration. We begin sometime between 130 and 70 BC, when Hero of Alexandria came up with an idea for the first steam engine.
Hi, I'm the Hero of Alexandria, and this is my invention. In the stove, fire heats water, which creates water vapor. It then comes up through this here tube and spins this machine. It really doesn't do anything.
Since the engine had no purpose, the idea of creating mechanical energy with water vapor was discontinued for nearly 2,000 years before anyone built a practical steam engine. The next generation of steam engines were built to pump water out of mines, so miners could get a lot more coal with water in the way.
Hello, I'm Thomas Savory, here with my great invention. Here, water is heated by this fire. Water vapor then creates pressure that lifts water out of the mines to make them drier, so that we can dig deeper. Here, water is lifted out of the mines. How's it going down there, boys?
Very dry, Mr. Savory.
Good to hear.
Savory's engine was very inefficient and costly to operate, so inventors worked hard to find a better, more efficient pump. Thomas Newcomen improved drastically on Savory's invention, and it was much more efficient.
Hello, I'm Thomas Newcomen, here with the latest and greatest technology to keep our mines dry. Here is my new system. This machine uses a piston inside a cylinder. When water is heated, water vapor comes up into this cylinder. It pushes a piston back and forth using atmospheric pressure and that causes this pump to go up and down, and that brings the water out of our mines.
Several decades later, James Watt was asked to repair a Newcomen steam engine. He saw all the flaws of the machine and sought out to invent a new and improved engine that was much more efficient.
Hello, I'm Mr. Watt. Well, I was working on one of Mr. Newcomen's engines. It had broke down and I had to fix it. I noticed there were many things that were strange about this system, and I knew that I could make it better, more efficient. So I designed my own system. It works like this. Steam enters through the steam entrance and comes into the cylinder, where it pushes a piston across the cylinder. Then, as you can see over here, the steam exits through the exhaust valve. However, as the piston comes across, this valve rod is turned, so more steam can enter through the steam entrance, through this tube here, and push the piston back across the other way.
The steam engine was used for many things, such as powering trains. We still use steam to convert kinetic energy into different kinds, although today we mainly use steam turbines for electricity. Finally, the engine we use today for most motorized vehicles is the internal combustion engine.
Hi, I'm Sam Hendry, and every single day I spend tons of time in a motorized vehicle that runs off one of these internal combustion engines. Here's how it works. The internal combustion engine involves a four-step process. During the first step, the intake valve opens and the position moves downwards, drawing a mixture of air and fuel into the chamber. In the second step, the intake valve is closed and the piston moves up, compressing the air and fuel mixture. In the third step, things heat up. The spark plug produces a spark that ignites the mixture. As the mixture burns, hot gases push the piston back down. In the final step, because the piston is pushed back down, this opens up the exhaust valve, releasing all the burnt gases. The process then restarts at number one, over and over and over again.
As you've now seen over the years, there have been many trial and error processes which led to the discovering of the laws of thermodynamics, as well as creating a better and more efficient engine. This has led to what we know today of how the laws of thermodynamics define how we understand energy conversions. As well, the process of developing a more efficient engine isn't over yet either. We still have yet to discover a near-perfect design.